Hi all, good day to everyone. Uh, my name is Muhammad Niza bin Muhammad Nasir. I am proudly to represent my group members in the topic of mathematical model of a novel fiber braided bending actuator. My group members consist of me, myself, uh, Dr. Ilina Jaimi, Professor I-RITEC Dr. Ahmad Atif, Muhammad Naji Muftah, and Muhammad Akmal Muhammad Yusuf. First, I would like to tell a little backstory about our project, the problem statement that led to our development of fiber braided bending angle in terms of control. Rehabilitation robots can help patients to have their treatments even at home. Although high deformation capability is reported from soft actuator performance, used as authorities, the common method used for controlling the amount of air pressure supplied to the actuator is by valve sequencing. What's the meaning of valve sequencing is by turning on the valve for some duration of time, pressurize the actuator, and then turning off the valve to either hold or deflate it using PWM method. Unfortunately, valve sequencing is not suitable for a system which the behavior of the input pressure cannot be expected. Accuracy in controlling a motion is most desirable, especially in medical robotics application. It creates challenges in modeling and controlling and obtaining low response time due to their material, air compressibility, significant mechanical friction, poor damping ability, and valve dead zone issues. The uncertainties makes the modeling and control of soft actuator more complex. The implementation of a control system can be quite difficult as a soft actuator are highly nonlinear and have infinite parameters. Therefore, numerous improvements are necessary to achieve the most optimal control capability. The previous fiber braided bending actuator system was an open loop without any control mechanism. In the previous project, there is no accurate and precise control of FBBA being developed. Okay, what is FBBA? FBBA is the acronym for fiber braided bending actuator. The innovation objective of our project is to formulate a mathematical model of FBBA for bending angle control and to construct an optimal PID controller for bending angle control of FBBA. So in the mathematical modeling, we propose a system identification using a auto-regressive exogenous, in short ERX, model in MATLAB system identification tool. And for the PID optimization, we propose two ways to optimize the controller. One of the ways is genetic algorithm and the other is auto-tuning method. Uses and application. FBBA mathematical model can be used as a planned representation for further studies to be conducted on the optimization of the FBBA bending angle control system. This approach can lead to improved performance of the FBBA, which can have practical application in robotics field, including object manipulation and finger rehabilitation. The implementation level of our project, we mark it as TRL4. TRL means technology readiness level. The innovation product / project impact. A mathematical model was formulated from the system identification method using I-RITEC model in MATLAB system identification tool. The tool is to achieve a high precision closed loop control system. The formulated mathematical model was evaluated in both simulation and experimental setup. I-RITEC 331, the third order of the I-RITEC autoregressive model structure, was chosen as the parametric model for further studies FBBA system due to its good best fit value, which is 94.34%, and the stability of the model is why we choose it. Genetic algorithm, in short GA, and automatic tuning methods were used as the optimization techniques to get the PID controller parameter to control the FBBA bending angle in the simulation setup. From the simulation based control setup result, the GA tune PID outperformed the auto tune PID with a rise time of 1.26 seconds and a settling time of 2.29 seconds with a impressive 0% overshoot. The same pattern is also observed from the experimental based control result where GA-tuned PID outperformed the auto-tuned PID. The mathematical model obtained is concluded to be reliable in representing the actual FBBA system. The authenticity and novelty of our project. A reliable FBBA mathematical model is formulated using SI black box method to achieve improved performance of the soft actuator bending angle control. The reliability of the mathematical model was evaluated through both simulation and experimental test result of the bending angle control. So here we can see the actual FBBA in action. You have multiple degree of bending here. So this is the interesting part. The simulation, both of the figures shows the simulation and experimental result. The simulation result control performance of the FBBA mathematical modeling, which can see that PID GA shows a better performance than auto-tune, and it is the same in the experimental result where PID GA also perform better than PID auto-tune. So here are some publications that have been done by this project. A Q2 journal paper which is published in MDPI, and a Scopus Index journal paper which are accepted for review and correction. Next, I will show the demonstration for the controlling of the real experimental of FBBA. So right here is the actual FBBA with the optimized genetic algorithm controller PID tuned by GA, which have a multi-step input signal which translated into angle is 100 degree, 80 degree, and now is 50 degree, and lastly is 0 degree. Okay, it shows that the actual FBBA follows the desired angle given by the input signal. That's all from me. Thank you for listening, and I hope you enjoyed the presentation. Bye.